Hi, hello. My name is Jochen van Guyse at Cisco, part of the global specialist team looking after automation. And with me here is Pedro Brites, who is part of the same team as myself. So we want to talk to you a little bit about routed optical networking, and specifically how do we automate that. So we'll take you through a few points today. First of all, what is routed optical network and why do we do it in the first place? You know, what is it all about? Then why does it need automating, right? What challenges does it present for the service providers that go and deploy it? How they need to run their networks, and how do we help them with our automation solutions to kind of get this working for them in a way that they can consume it at scale. And then we'll show a little bit about the hierarchical architecture of how we do that. It's the same architecture that Rana talked about in the previous solution, and then we'll give a demo of that hierarchical system that sits at the top of our automation controller stack. So first of all, why run, and what do we actually do with that? So as you see here on the screen, we have the old way at the top of how we used to build network, and let's say the new way of how we used to build networks at the bottom. They're very similar. You have a router, and it needs to be connected to something called a ROADM, which is an optical networking switch that switches wavelengths through the optical network. Now, the way that used to be done was that the router would be connected with a gray optic that goes into the router, and it would have a fiber jumper cable. It would go into another gray optic, which sits in a transponder, and that transponder is ultimately connected to the ROADM over a colored wavelength, so one of L-band or C-band wavelengths. Now what we're doing here is we're changing that whole setup, and we are putting an optic straight in the router, connecting with a single fiber jumper cable, and that goes straight into the ROADM, and the colored optical wavelength comes straight out of the optic that sits in the router, rather than basically having first a gray path to a transponder and then a colored path through the network. It now goes colored straight from the router through the network. Now, this has a lot of benefits. First of all, you're cutting out a whole bunch of equipment, right? You don't need that gray optic, that other gray optic and that transponder anymore. You just need a colored optic and a fiber jumper cable. So first of all, in terms of reliability, that has its advantages. You're cutting out a number of stages and of equipment. Secondly, in terms of power, that has very big advantages. These things all consume power, and this is a way more effective means of having a low watt, high speed capacity over your networks. It also reduces space, right? Rack space. You don't need all these transponder shelves anymore in the service provider. You can reduce that. So overall, there is CapEx advantages to this. And overall, there is OpEx advantages to this. You don't need less power, you need less space, and so forth, right? So that's why we're doing RON. Now, why do we need to automate RON? Because it poses some challenges. And those challenges come from the fact that we used to be working in silos, and we still are working in silos, or service providers are still working in silos. We have an optical networking team, we have an IP networking team, and the optical guys, they are the ones in control of, you know, the transponders, and they are choosing the wavelengths to go across the network. And now some of their equipment that is dialing into those wavelengths now sits in a router, which is in the other team, right? That's managed by the IP team. Now the IP team probably doesn't have all the details that they need to be able to, you know, tune that laser to the right frequency and be able to manage that. So what we need to do here is to put some software solutions over the top of that in order to give the optical team the ability to control that and give an overall view of the network. And so that's what we're doing, and we're using the same software products that Rana was talking about and Tom were talking about before. We have our Cisco CNC and our Cisco HCO that we covered in the last presentation, and we have a number of stages of how we enable this capability, starting from, you know, people that don't have these controllers in place yet. How would they, if you don't have CNC yet and you're managing your network in a different way, in the classical way before all of these controllers existed. You know, how do you do that? What do we do for people that do have that capability, and how do we basically move that across? So this is the view that you saw earlier from Rana. We have the hierarchical controller at the top, an IP domain controller that is like CNC, but it could be another vendors as well. That is managing the IP equipment, and then we have an optical controller, which is managing the optical equipment. And there could be multiple of those, right? You may have multiple IP domains, you may have multiple optical domains. So what we're going to show you now, or what Pedro is going to show you now, is how we apply that, and we're going to just show you a demo of our system and how you would use that to kind of look at an overall optical network, RON network, and how that would be automated. Thank you.
Thank you, Jochen. Hello, everyone. So as Jochen said, I'm going to walk you guys through some of the demo. So I'll be playing with two systems because I'm limited to what we're using this system in the floor as well, and we're doing demos all the time to customers. So I don't want to upset too much my colleagues. But so you can, if you're interested in to know more about this demo, so that's Net 06 in the world of solutions. Happy to have a more deep dive discussion if you're interested to know more about this. Let me quickly walk you through the one of the setups we are running. So this is the setup we're running on the floor as well, and I'll be demonstrate some of these functions. So what we've got here is 8201 that's acting as one of the routers where we're going to plug that transponder type on an SFP format. So it goes into this router. Then what we have here, it's an open line system. In this case, we are using Cisco, but it could be Sienna, it could be Nokia. We don't care. We are multi-vendor, so we can integrate with any other OLSs as well. And then finally, we have on the other hand the other router. And then so I'm going to show you the turn up, how easy it is to set up this IP link end to end, provisioning also within the OLS. And the second thing, it's I'm going to create a fault, and you're going to see how easy also to troubleshoot a fault. Even we're here mixing the layers a bit between IP and optic.
Live demo, brave man.
Yes, yes, oh, I like it. So first thing, color schemes that we have seen here, right? So in blue, as you might guess, is IP network. Circles, blue circles are devices, IP devices. And then in white, I have the ability to spread the layers as well. So in white is our IP domain, optic domain. In this case, we actually doing two optic domains, and this is the beauty of this hierarchical architecture, because we can bring these multiple domains, even if it's on the same layer, if it's optic, we can have 1, 2, 3, 4 domains in a single screen, make it easier for people for the operations. So this brings the operation simplicity to the table, right? So if I use like my tags here, where I can manipulate the view, so I can just look at one of the domains. So now I'm just looking at the domain where we're going to create the service. And then obviously I can also look at my topology, my IP topology. For instance, if I'm only interested to see where I got my RON links, so I also can manipulate that with tags. So I come here and then I can see just my RON links as a visualization. So we have all the, so this can be to IP and optic guys, both can use this platform because it's like a single pane of glass that we're looking. If I drill down, let me bring to multi-layer. So if I'll drill down in one of the principal sites, so we can see there is a device as I click on the device, I get to see details about this device, like which type, management, what version of software is running. I can see the tags that I'm using, so we don't have a hard limit on the tags, so I can have multiple tags as I wish, and any of the applications can use these tags. And then I can also look at my optic devices in the same site, because I could have optic devices in the same site. In this case, I got two ROADMs there is a 2K and a 1010. And then I can see crosslinks. So what are crosslinks? Crosslinks is where we plug the router to the ROADM. So it's those back-to-back connections, so the physical connections inside the site. So I can also view, I can also have a view on those. And the other thing is, when I click on the links here, we can see now we got two more color schemes. So we got the orange, which is the link I've clicked, and now in green I'm highlighting the optic path. So this is the optic path that this IP link is taking. So I'm now really bringing this correlation, and this is why we are proposing this hierarchy controller of the controllers, so we can bring this multi-layer view. So let me now just play a quick video to show you the turn up, how easy it is to do the turn up. So we have applications that have different roles. So now I'm going to go now into Service Manager. So here it's the application where we do the turn up of this link. So the first thing, obviously, we need to put a name that we're going to give to the IP link itself. And then we're going to select, the next thing is selecting the rate. Do I want 100 gig, 4 times 100 gig? In this case, I want a 400 gig circuit. Then the next step, and you see it's picking the site. So I'm now going to select the site. And the good thing we do with our tool is, when I go to select the interface, the only interface that appears is the only that is capable of carrying this service. I'm not going to get the full list of interfaces in the router. And then the next thing is going to site B, and I'll do the same process. So picking the site, and then the next thing is I'll be picking the interface. So now picking the site, B site, now the interface on B site. And at this point, I'm now going to define my IP addressing that I want to use for my IP link. In this case, I'm going to use /24 because it's what my colleagues in the lab, they like to use. But it could be just a /31, so no limitation here on the system. And then the next thing is to define, so if I know what I'm doing, I can select C-band, L-band, or I can just leave that for the controller, and the optic controller will give me that information in the background. So now I got a summary, and at this point in time, I'm pushing the configs, and I'm talking to the optic controller. Give me the alien wavelength between this point and this point, and tell me which frequency are you using for it. Then it's going to reply with the frequency, and then I'm going to go back and I'm going to talk to the IP controller and say, now you need to do this configuration into these devices, into these pluggables, so we can establish this IP link. So that's what he's doing now in the background. So he's creating all of that. So this process takes around 3-4 minutes, and then we're going to see the link. So this point.
Does your system also know how many wavelengths still available on a physical link?
Yeah, so the optic controller takes responsibility to make that decision and give you the best one for the service.
This available, okay. But you can say there is still something available, or the link is already totally utilized, yeah?
Exactly. You also have the ability to specify, I want to use this specific alien wavelength, this specific frequency for this, and they also push that into the optic controller.
I'm coming not from the optical world, but is it like this, that then you have also maybe links that are better versus you can have several service classes on these different, and then you can make decisions on those?
Correct.
I think it's also dependable on from the distance, right?
Exactly. So the distance, fiber quality, there's all these factors, right? So
Is there anything in the platform that would suggest what you should use? Is there
So
like
that's
any
what-
proactive testing that it does that would then
Yes.
say?
So when you do the planning inside the OLS, so inside the optic domain, so you have to take in consideration all of that, like distance, attenuation, and so on. And in this case, what I've done, I left that judgment to the controller. I didn't specify I want to use this one. So I left that for the controller. I said, I want a alien wavelet for this service, and it's going to give me the next best available to do that. With the service. So this is the link that we've created in this video. So now I'm back to the system again. Again, as you can see, is highlighting the path and the optic path that is taking, and then we can do used by, and then we see there is an IGP link here, and then we can switch to the path. So the view that my colleague showed before, where you have the multiple layers. And this is obviously here I don't have a service, but this is where we get that visibility from service, in this case layer 3 VPNs, layer 2 VPNs, down to the fiber. And if you get a fault, which I'm going to create a fault. So let me create a fiber cut. So I'm going to create a fiber cut here at this point between Benevento and Battipaglia.
Hate fiber cuts. Normally, somebody with a digger now needs to go to that location. Yeah.
Exactly. So
luckily are wonderful locations.
So at some point, so we're going to get, because we subscribe the notifications of the, and we see, so now the fault is live. So we it turned red because we subscribe to the notifications of these optical and IP controllers, so we can be near real time. So not in seconds, but a few seconds, right? Not sub-second, but within the seconds. The other thing so we have this ability to also help the troubleshooting. As I mentioned, we kind of merging the layers here, and there is some I would say either the IP team would say, oh, now I'm not touching this. I don't know how this works. And then, or you have the optic guy, oh, I don't want to connect to the router and see what's going on, right? So we come up with this application that's called Link Assurance that really helps to demystify that, right? So I can, I'm leveraging the tags to pull all the wrong links. And then hopefully we're going to see, it's going to tell me all the links. So this is the one where I create the fault, and the fault is still being propagated across that. But we can see already that the OTS here, it's down, right? So operational status down. We can look at the events and say it went from up to down at this timestamp. The other thing we have built into the system is the ability to look into this optic KPIs as well, ingesting this from the optic domain controller. So let me show you one that's up and running at the moment, where we can really see those. So here we can we're ingesting the power levels. We can look at this from a time series and see how the link's been behaving along the time. Or we can also look into the wavelength and see how it's been performing. So I can look into KPIs like Q margin and Q factor. So this tells about the quality of the fiber, how it's been the performance along the time. Any questions so far? Great, thank you. So we also do, one of the other big use cases we are addressing with this platform is, just log into this system. One of the use cases we are addressing, and we perceive that it's a big issue for service providers that try to automate, is fixing inventory. So with this, we're helping service providers fixing their inventory issue. The reason is because our hierarchical controller does not allow users to input data. So all the data about the devices, the network, the topology needs to be discovered, which becomes, we in this case become a single source of truth for this integration. So we've been doing this use cases with some of the major service providers in Europe, where we're fixing their inventory system as the first step then to build up the use cases into the automation later on. The other thing is we're also simplifying operations to make it easier for the level 1 NOC guys to pinpoint where is the problem, which team should I pass this ticket on, right? And I think you touched on that problem, see how you could correlate the fiber to the layer 3 VPN that's down, right? So we do that automatically here. So we call this RCA. So it's the stands for root cause analysis. What this application does is it looks at everything that's down and reports. So this is what is down. So if you look at this event here, for instance, it's an OMS that's down, but it is impacting 727 links. And by links, we refer to a layer 2 VPN SR policy. In our model, they are all called links. Okay, and
so
then
is there, sorry to jumping in. So is there something like, more proactive? So like take it the other way around, and basically getting the info like, there's some sort of like a shared faith. So if that link will go down, it will cut off all these services. Maybe you should more balance these services between the different physical links.
Absolutely. So that's I'll touch on that application in a few moments.
Okay. Perfect.
So this is a reactive one, but we have the proactive side of things,
perfect.
which I'll come back to you. So now the level 1 NOC guy, the only thing he just needs to do is click on the event, and now and bang, he gets the full correlation. This is all the layers that are down, inclusive. So now you can see the layer 3 VPN. Now you can say, oh, now I know why this customer is calling me. It's because of this fiber cut. So I don't need to talk to my IP team. What I need is to talk to my optic team and get this OMS fixed. The vision we're taking this product as well is so you can go from here and launch the optic domain. So this way you can then drill down into the fault and understand where this fault is coming on without jumping between and doing multiple sign-ons and so on. So we're going to simplify that and do this across launch, not just on Cisco. So be open to integrate it with other platforms. So on the other front, so we have the ability to do failure impact analysis, and here I can go and select a device, or I'm going to send an engineer to replace a card, or I'm going to do a fiber maintenance. So I can then simulate that. So for instance, if I select a resource here and I go to the 3D map, for instance, so let's say if I pick this fiber here, and I'm going to take this fiber down. So let's have a look and generate this report. So now I'm doing a failure analysis and said, if this fiber goes down, what's going to be my impact? Because I'm going to do a planned maintenance. So this way I can see, okay, so I'm going to fail 2 IP links. So this is the IP links I'm going to fail. I'm going to fail 2 Ethernet circuits, 2 ODUs, and 62 LSP is going to be impacted, but not going to be down. So we were able to find alternative paths, but they're going to be rerouted. So now you can really copy this and put it into your ticket and notify the team. So we're going to do this intervention, and this is the impact we're going to cause. So, and with this, I finished my demo. Open for more questions or anything that you would like to see or ask about the product.
Do you have like an over time historical record of if things have failed, like if hardware has failed? Just thinking that you're cross vendor, if you start to see, okay, this particular model we're noticing is breaking down more often, why don't we go in and proactively replace those because we can see that there's a trend that we're getting issues with them? Is that something that you can bubble up to the surface?
It's a good point. Actually, I forgot to mention, we have a built-in time machine that allows, combined with an application that we call History app. So let's say we know, oh, this OMS has been going up and down. We can do a filter, we can do the query, and say, and you're going to tell you how often it's been down. And then you, by clicking that event, you activate the time machine into that time stamp, and you can see that, and it's like doing a replay of the fault without touching the network.
Yeah. There's something also for the future, like a sort of what if analysis. If something, what happened if some, predictive model, and if some fault happen, what are the impact on the service?
So this, what I show this, we're shipping.
Okay.
This is not, what we are not shipping, the things I mentioned is the cross launch, the ability to do the cross launch. That's still not GA. It's work in progress, but all the functionality I've shown here, we're shipping. It's GA and we're shipping it.